Okay, so we have chapter 7, 1 and 2, adding and subtracting fractions with like denominators. We said that like is the same thing as same, and denominator is the bottom number of a fraction, which is known as the whole. Okay, and D, down, okay? So think of down as the number on bottom. Then we're looking at the example. Brian, can you read that for us again?
Jessie is hiking along a 1-mile trail in the Lake Tahoe area. She hikes 1/8 mile and stops to take a photograph of the scenery. After another 3/8 miles, she stops again to take more photographs. How far has she hiked?
Okay, so we have one whole. Fractions are less than one whole, okay? And right now, they are splitting it up into 8. So I'm going to compare it to this one whole, and when I have a fraction of 8s, my one whole is split into how many parts? 8. Okay, and each is worth 1/8. Okay, so right now it says she hiked 1/8 of a mile, so I have that 1/8 right there. And then she stopped to take some photographs of the scenery. Then she traveled another 3/8 of a mile, so we need 3/8 more, 1/8, 1/8, 1/8. So this represents the 3/8, okay, that she hiked. And then she stopped again to take some photographs. So we want to know how far has she hiked. So we're taking the 1/8 that we had here from the first one, plus the 3/8 that she continued to hike on, and then we're going to find out how far has she hiked so far, okay? Telling me that so far, how far has she hiked, we're adding it on, so therefore our operation is to add. So we're going to add 1/8 and 3/8. The great thing about fractions with like denominators, you don't need to do anything. They're already in the same format. They're all 8s. So you just keep the denominator the same, but the numerator is what's going to change. So we have 1/8 and then we have 3/8. So how many 8s do we have altogether then, everyone?
4/8.
4/8. Very good. But in fractions, a lot of times they are not simplified, okay? So 4/8 is not simplified, and we always want the simplest fraction possible. That's why when you guys think back to chapter 1 and you learn factors and you guys learned how to do the trees and all of that, this is where it's going to help you. What is a factor of 4 and 8 that they both have in common? The biggest factor, the greatest common factor they have. Kyra?
4.
4. So since we know that 4 is the greatest common factor we have for both of these numbers, I can divide each of these by 4. So 4 divided by 4 will give me 1, and 8 divided by 4 gives me 2. So, and when I look at the visual, look here, guys, you can tell that it's taking up exactly at the halfway point. So half of this and half of this, they're the same. They're equivalent, okay? 4/8 is the same as saying 1/2. So how far did Jessie hike? I'm not done yet. I have my answer, but I need the label. I need the label. The label tells me the answer to the question. 1/2 means nothing to me if I don't answer the question that it's asking for. So Varsha, what is the label that I need?
1/2 mile.
Very good. Mile. What is the distance that Jessie traveled on his hike? Okay? Okay, Nishant's going to read us the example on page 147.
The next day, Jessie hiked a 7/8 mile trail. She photographed an osprey at the 5/8 mile point. How far from the end of the trail did Jessie see the osprey?
Okay, so again, we want to think of this as in comparison to one whole, right? So if we have the fraction bar one whole here, and again, we're still on the same hiking trail, and so everything's broken up into 8s. Okay? And we see that Jessie hiked a 7/8 mile trail. So this time, the trail is only how long? 7/8. So it's only 7/8 long, okay? So I'm going to fill it in till this. All right, so we have 7/8 minus 5/8 equals 2/8. We knew that it was minus because we're seeing how far from the end of the trail that she's already traveled, so we're taking that away. We got 2/8, and then we knew that it wasn't in simplest form, so we divided each side by 2, okay, because it's the greatest common factor, and we got 1/4 mile from the end of the trail. Okay, so correction, good point was brought up that it should be 1/4 of a 7/8 mile trail, okay? Because it's not, the trail is not 1 mile long, it's actually 7/8. So we made a little correction there. Okay. Okay, so in lesson 2, so I'm now moving on to lesson 2. You guys saw how it works if you were to have a visual picture of it, but now in lesson 2, we're going to do it so without using tiles. How would you figure out the answer to these questions without using tiles? So let's look at example 1. Elizabeth, can you read that for us? Manuel.
Manuel eats the recommended servings of vegetables each day. He ate 1/10 at breakfast and 7/10 at lunch. What fraction of the recommended servings of vegetable has been eaten?
Okay. So as she was reading, I wrote down the important information. I had 1/10 was eaten at breakfast of the vegetables and 7/10 at lunch. Okay. And the question is asking us what fraction of the recommended servings of vegetables has he eaten? What is the recommended servings? What is the whole? Aniket?
10.
Exactly, 10. Look at the denominator, the whole, right? The denominator is always representing the whole, and so in order to have all the servings you need, you would need 10 of those servings, right, to make the whole. Right now, we only have 1/10 from breakfast that she ate and 7/10 from lunch that she ate. So what kind of operation am I going to do here to figure out what the answer to this question is? Vedant? Addition. Very good. How did you know it was addition?
Because they're saying how much she would have ate in total, or the recommended servings she ate. And if you want to find it, you have to combine both of the things she ate, which is breakfast and
Lunch.
lunch.
Very good.
And then that's the answer.
Yes, very good. So we take 1/10 plus 7/10. So think back to the first lesson, right? If the denominator is the same, do we need to worry about that? No. So we just carry it over, write the 10 as is. The thing that's going to change is the numerator. She ate 1/10 at breakfast and 7/10 at lunch. And if we're combining those two, that gives us, everyone?
8/10.
Very good, 8/10. Okay, now is 8/10 in simplest form?
No.
No, it's not. What is the GCF? What is the GCF? Yuna? Is what? No, what are you dividing each? What is the greatest common factor they have?
The greatest common factor they have is
2. Very good. So I'm dividing each side by 2. Good. And when I do that, what do I get, Yuna? Okay, so 4/5. Am I done yet? No, I didn't answer the question, right? I don't have a label here. The question was asking for what fraction of the recommended servings of vegetables has he eaten. I have the fraction part, which is 4/5, but I need the label. 4/5 of what?
of the recommended.
Right, of the recommended servings of vegetables. So example 2, Milana. Elsie's.
Elsie's recipe for grilled eggplant uses 7/8 cup of diced eggplant. Tran's recipe calls for 3/8 cup. How much more eggplant does Elsie's recipe need than Tran's recipe?
Okay, so we have 7/8 cup of eggplant from Elsie's recipe. And then we have 3/8 from Tran's recipe. And the question was asking us how much more. When I hear that word, how much more, what should be triggered in my head? What operation should I be thinking in my head? Evan. Huh? How much more? Subtraction, right? You're comparing, right? So subtraction is what you should be thinking in your head that's going to happen. So if I take 7/8, which was Elsie's recipe, compared to 3/8 from Tran's recipe, I have a difference of how much? 7/8 minus 3/8, the 8 stays the same, and 7 minus 3 is 4. Okay, and is this in simplest form? No, it is not in simplest form. So what do I need to do? What do I need to do, Brian? Yes, and what is the greatest common factor? Thank you. So you're dividing each side by 4. So 4 divided by 4 equals? And 8 divided by 4 equals? 2. So we have 1/2 here, okay? So 1/2 of Elsie's recipe, which one has more? Which one has more eggplant? Which one is using more eggplant? Elizabeth? Yeah, Elsie's recipe needs 1/2 cup more eggplant. So Elsie's recipe needs 1/2 cup more
Shouldn't it be Trans?
eggplant.
Because Trans.
Can you raise your hand, please? Thank you.